Hello, my name is Amabella Maicasilia.
Annyeonghaseyo, my name is Alexa Sarmiento.
Bonjour, my name is Adrian David Yalo.
And we are
We are
Triple A.
Triple A.
And we are
Now let's talk about our lesson proper, and we will start with scientific knowledge. I know, science, philosophy, sounds like a burden, right? However, in scooping answers in philosophy, nagsascience tayo, consciously and unconsciously. And this is scientific knowledge. As we observe the world, we notice certain regularities and irregularities. Pero ano nga ba yung regularities and irregularities sa philosophy? Well, regularities are those things that show patterns and consistency concerning philosophical domains. Example nito ay yung sunrise and sunset. Regular na umangat ang araw sa east and lumulubog naman ito sa west. Hindi pwedeng magkaiba or vice versa. While yung irregularities naman ay kasalungat ng regularities, where it points out the absence of patterns and deviations from different philosophical norms. Example nito ay yung mga puno. May mga punong namumulaklak at namumunga. Mayroon namang hindi. Kung saan dito natin may kita na irregular pala ang pamumulaklak at pamumunga ng mga puno. Through these two, they bridge our questions to philosophical answers through scientific knowledge. But why are we interested in discovering these regularities? According to John Hospers, it is because we are thirsty for knowledge and predicting the future. It interests us. Overall, science is the systematic search for uniformities in the way things behave. And these are called the laws of nature. Nature and laws, what are they?
First, let's start with the laws of nature. First, let's define the meaning of law. I know you're already familiar with this term since we often encounter this sa mga news sa television, newspaper, etc. But still, let's define this term. Law, a command that has been issued by a head of state or enacted by a legislative body. Laws, in this sense, are prescriptive, which means they prescribe how the people within its jurisdiction are supposed to behave or not behave. They are imperatives, which means do this, don't do that. Kumbaga, parang minamanduhan nila tayo kung ano yung mga dapat natin gawin. For example, in the Philippines, we follow all the laws. Yung mga law na pinapatupad sa bawat bansa ay example ng prescriptive law, which means na we should strictly follow all these orders kasi if we did not, we would be punished unless you have a connection sa nakakataas sa government. Charot. Let's move on sa laws of nature. It is different from prescriptive law since this law is descriptive and more likely it is a detailed explanation of something in the world. Para mas clear, let's define the laws of nature. Laws of nature. In the philosophy of science, a law of nature is a claimed regularity in the relationships or order of events in the world that holds, under a certain set of circumstances, either globally or in a claimed proportion of instances. That's according to Britannica 2023. Laws of nature are not prescriptions, but descriptions of how nature works. For example, the laws of planetary motion. Johannes Kepler did not prescribe to the planets that they should move in such and such orbits, with penalties invoked if they should fail. Rather, they describe how planets actually do move. Only conscious beings can prescribe, since only they are capable of giving orders. But the uniformities of nature would still occur even if there were no human beings to describe them. Basically, human beings are the only individuals that are capable of prescribing since sila lang yung kaya gumawa ng batas or ng order na pinapalaganap nila sa bansa. Samantalang ang laws of nature ay mag-e-exist pa rin sa world kahit na walang humans ang makaka-describe sa kanila. Kasi nangyayari sila naturally, so we can and we will never be capable of controlling it. So for this part, let's differentiate naman ang meaning ng describe and prescribe. So unahin muna natin yung prescribe. It is a rule that should be carried out. It's either an action or procedure. For example, the law prescribes a prison sentence of at least 5 years for the crime. Next is describe. It is a verb that is used to convey the characteristics, qualities, or features of a person, place, thing, or event. It is often used to provide details or information. For example, the witness was asked to describe the suspect's appearance to the police. So may mga times na nako-confuse tayo sa meaning ng law, bakit may law, sinong gumawa ng law, bakit may law sa science. Several confusions can now be avoided by the following. First, laws should be obeyed. Law of nature is not the sort of thing you can just obey or disobey, since it is not an order or command anyone has given. Unlike the laws of the land which should be followed by people because disobeying the law is a problem in ethics. Second, where there's a lawmaker. This applies clearly to prescriptive law. If a course of action is prescribed, someone must have prescribed it. However, laws of nature are not prescriptions because they only describe how nature works. Third, laws are discovered, not made. This only applies to descriptive laws or laws of nature. We discover how nature works. We do not make it work that way. But the formulation of these uniformities is the work of human beings. Laws of nature constitute a smaller class of propositions than empirical statements in general. So what is an empirical statement? Empirical statement, it refers to any statement whose truth can be confirmed by observation of the world. For example, naglalakad tayo sa farm, tapos we saw a chicken na naglalay ng eggs niya. So dahil sa pag-observe natin, na-confirm natin na chickens can lay eggs pala. We can say na seeing is believing, but the belief can still be wrong. For example, halos lahat ng fire trucks na nakita mo are color red. Pero it doesn't mean na porket red yung mga fire trucks na nakita mo, ay puro red na yung fire trucks all over the world. Kasi in some countries, iba yung color ng fire trucks nila, like merong yellow, blue, etc. Basically, hindi lahat ng no-observe natin ay tama. Laws of nature are special class of empirical statements since these laws are at the very core of the empirical sciences, like physics, chemistry, astronomy, geology, biology, psychology, sociology, economics. It is important to know what they really are. So there is this question. When can a statement be considered a law of nature? First, a law of nature is a universal statement of the form all A's are B's, or if something is an A, then it is or has B. So basically, kapag may letter A, laging may kasamang letter B. Parang mag-best friend, sanggang dikit sila yung tipong di sila mapaghiwalay, like hindi sila kumpleto kung wala yung presence ng bawat isa. Here are some scientific examples. All iron rusts when exposed to oxygen. Second, all copper conducts electricity. So, let's move on naman sa susunod. A law of nature must be open-minded. It must have an unlimited range in time and space. One real-life example of this is, if there is a car, then there are wheels, because cars cannot move without wheels. Some scientific example, whenever and wherever there is an A, it will be or have B. Wherever there is iron, it is magnetic. Wherever there is lead, it melts at 327.5 degrees Celsius. Third naman, natural laws must be expressible as hypothetical statements. Natural laws are often expressed as hypothetical statements in the form of scientific hypotheses or theories. These hypotheses and theories are formulated to describe and explain the regular patterns and relationships observed in the natural world. They are typically stated in a conditional or if-then form, as hypothetical statements in the form of scientific hypotheses or theories. These hypotheses and theories are formulated to describe and explain the regular patterns and relationships observed in the natural world. They are typically stated in a conditional or if-then form, making them hypothetical in nature. For example, consider Newton's second law of motion. If an object experiences a net force, then it will accelerate in the direction of that force, and the magnitude of the acceleration will be directly proportional to the force and inversely proportional to the mass of the object. This is a hypothetical statement that outlines a specific relationship between force, mass, and acceleration. Additional example, even if all crows we have ever seen have been black, we would be unlikely to count this as a law of nature because it is still possible that we might discover an albino crow. Fourth and last, the greater the generality of a statement, the more likely it is to be accorded the status of a law of nature. This is because laws of nature aim to describe broad and universal principles that apply to a wide range of phenomena, and they often serve as the foundation for understanding and explaining various natural phenomena. For example, if the melting point of lead were different from what it is, this would not affect much else in the universe. If some birds had 3 legs, this would not affect much besides birds.
Now, let's discuss explanation. First, what do we mean by explanation? According to Cambridge Dictionary, it refers to the reasons that one provides to clarify something or make it easy to understand. Scientific knowledge allows us to explain why many things occur as they do. On the other hand, there are cases where one does not require scientific knowledge to explain a particular phenomena. For example na lang, why is the door open? It was open because it's a hot day. Why are you reviewing those lessons? It is because I have a test tomorrow. Why are you watching a movie? To entertain myself. Explanations are not always answers to the question why. They could be merely a request for clarification or could be a step-by-step process on how to do something. For example, explain that passage in the song, explain how to build this thing, or explain how to use this application. We solely provide the inquirer how we do something or how something works, like how a device operates. Next, explanations are used in the scientific field wherein they are most concerned with explaining the why of events. We ask the reason why a particular phenomenon occurred. For example, yung why does oil turn cloudy in the fridge? It is because of the low temperature and the solidification of certain components in the fat. Another one, why did the water pipes explode in the cold weather? It is because water expands when it freezes. Moreover, we often ask how these events happen. And lastly, we introduce the use of theories for explaining a particular phenomenon. We can get far in explaining without introducing theories. Theories aid in providing concepts to figure out and explain what have been observed. For example, among other liquids, why does water expand when it freezes? This is where the theory comes in, where the chemist sheds light about the concept of the crystalline structure of water. Furthermore, theories refers to the elements stated in the explanation that could not be observed by our senses. For example, the molecular theory of water. Its molecules aren't visible to the naked eye, not even through the help of powerful microscopes, but we can infer its existence based on what we do see.
Now that we are done with the laws of nature, we move on to theory. But what is the theory? So according to a mere American dictionary, a theory is a well-substantiated explanation of an aspect of the natural world that can incorporate laws and hypotheses as well as facts. It is true because when we theorize, we intend to explain and utilize these laws, hypotheses, and facts. However, according to John Hospers, a theory is never proved or conclusively established. According to him, a theory is always subject to revision in the light of further investigation. Theory differs on various domains. Its definition depends on its domain. It's different in the domain of laws, domain of science, and different domains. But in the end, no scientific theory is forever impervious to disconfirmation. It is just that it takes much disconfirming evidence before an argument is abandoned.
Moving on to the next topic, where we introduce how theories are used in astronomy. A theory in astronomy. Seeing the moon, planets, and stars through the night sky looks like they all go around the Earth, and based on our senses, these celestial bodies appear to be that this planet we live in is at the center of the universe, and those celestial bodies move around it. Going back in the past, the ancient Greeks and Arabs noted that the sun, moon, and planets move among the stars, whereas the stars, although they move across the sky, never showed any changes of position in relation to one another, which means that the pattern of the constellations remained the same. It was explained in this theory that the visible celestial bodies were fixed on the interior surface of a hollow crystalline sphere. Each planet has its own sphere since they have different motions, while the stars were in the interior of the outermost sphere. However, it was believed that this theory of the crystalline spheres appeared to be slightly in conflict with the clearly observable fact. There was also this Egyptian astronomer Ptolemy who observed some peculiarities in the motion of the planets. For example, Jupiter will move slightly eastward among the stars and then temporarily go back and move westward in a retrograde motion. But why do these phenomena happen? Ptolemy believed that all celestial bodies move in circular motion called epicycles and rotates on the circumference of a larger circle called the deferent. Through various careful observations, it was found out that there were slight variations in a planetary motion. Thus, they had to explain or hypothesize them via introducing new epicycles. However, there were no general theories to support and predict that planets move in epicycles. On the other hand, astronomer Copernicus argued that the planets orbit around the Sun. The Earth, being closer to the Sun than Jupiter, moves faster in its orbit, and when it is rounding a bend, the more distant planet will appear to be going in the opposite direction for some time. This theory was perceived to be a simple and plausible explanation for the observed motions of the celestial bodies. However, the Copernican theory had one conflict. It had one observable consequence that did not follow the Ptolemaic. It was taken against him that if the Earth were going around the Sun in an orbit, there should have been some evidence of a parallax. Yung parallax na ito refers to the slight difference in the position of the nearer star in relation to the more distant ones. However, he has no empirical evidence to support his claim. Through careful telescopic observations, there were no parallax observed, which was the evidence that countered Copernicus' view. Later on, his theory was proven right when the first parallax was discovered in 1833. These two theories both had explanations for the same observed data. Copernicus' theory was a simple and plausible explanation for the observed motions of stars and planets through the sky. However, Ptolemy's theory was inconvenient as there is still a need to hypothesize a new epicycle since its motion changes. If one of the theories were explained simply, which merely requires a few general principles, then it is likely to be accepted. The simplest theory may not account for all the facts, since it may not be able to explain the complexities of a phenomenon. If the simple theory explained all the observed facts at the time, there are possibilities for it to be inadequate in explaining, since it may be incompatible with the new discovery of facts. If the simple theory can explain all that is required, then it is accepted, like Copernicus did even before proving the evidence for a parallax. A simple theory is neat, tidy, elegant, and aesthetically pleasing. It has been a long goal of science to make sure that simple theories and explain them as little as possible for us to easily understand them. To accept the simplest theory is based on the precept, Occam's razor, entities are not to be multiplied without necessity, which means to keep things as simple as possible, and according to William of Occam, if you have two ideas that could explain the same phenomenon, you should select the simpler one.
Next, we have a theory in geology. This is a theory that includes data from astronomy and biology. with one science reinforcing the observational data of other sciences to form a coherent, unified theory. Fossilized remains. The fossilized remains of many large reptiles, including dinosaurs, have been dug up for more than a century in various places on Earth. These reptiles flourished for more than 100 million years until about 65 million years ago. They disappeared from the Earth quite suddenly. Thin layer of clay. A thin layer of clay was discovered in a deep gorge in Italy, in strata of rock at the boundary between the Cretaceous period and Tertiary period, laid down during the period in which the dinosaurs became extinct. So what? Ano nga bang purpose ng mga info na to? In this layer, large quantities of iridium were found, a metal rarely encountered on the Earth's surface, but 10,000 times the normal amount was found in this layer. Iridium is heavy and would tend to go downward while the Earth was still molten. There were two theories that would explain the presence of iridium. Was it spewed out through volcanic activity, or did it fall to Earth in a collision with an asteroid or a comet? Which theory was correct? Deposits of iridium. Other deposits of iridium from the same period were discovered, and geologists found grains of quartz that looked cracked and strained. No such thing had been seen before except near meteorite craters at nuclear bomb test sites and on the moon. Geologists could figure out only one way in which quartz with these features could be formed, namely when subjected to enormous heat and pressure from powerful explosion. Extinct animals. Biologists had been busy compiling a list of animals that had become extinct during the last half-billion years. The extinctions showed a recurring pattern, continuous long periods of evolution, then a brief period when they disappeared. There was a definite periodicity to these extinctions, recurring cycles of about 26 million years. How was that turn to be explained? Ice ages were much too short. The explanation was extraterrestrial solar flares or supernovae. However, these theories were tentatively rejected for lack of evidence. It was pointed out that most stars are double stars, not visible through telescopes or photographs but detectable by their gravitational effect on the stars. During the 1,000 years that it's far away, it has little effect on the solar system. But when it nears the sun, it moves much faster, as comets do when they approach the sun. Next is Oort cloud. Beyond the orbit of Pluto, the furthest planet from the sun is a vast array of comets called the Oort cloud. When the sun's invisible companion, astronomers hypothesize, intersect the Oort cloud about 26 million years, it carries with it, through gravitational attraction, many of these comets, some of which are drawn into the Earth's orbit. The 26 million year cycle has now been repeatedly confirmed. The missing link in the puzzle is still the sun's dark companion, which has never been detected. This account illustrates the following. Empirical science is a vast, interconnected network of facts, laws, and theories. The system must be coherent. If any inconsistency is found within it, it must be removed. Perhaps what was thought to be an observed fact was an observational error. Perhaps a fact was misinterpreted if neither of these things has happened, and an inconsistency remains. Something will have to give way. Some fact reinterpreted. Some theory abandoned or revised. Second, the testing procedures are interdependent. We assume that there is a correlation between the two materials or objects, two things that are dependent on each other. For example, let's assume that there is a correlation between a rise in temperature and the rise of mercury in a tube. This is not an assumption, since it has been confirmed countless times for several centuries. Third, let us notice what assumptions we are willing to make if they are coherent with an already confirmed theory. This controversy involves many hypotheses, educated guesses as to what happened way back then, with lines of inductive evidence going one way or another. but they do not involve theory in the strict sense. They deal with macroscopic objects available to our senses, not with unobservable entities that aren't available even to microscopes and telescopes. Iridium rocks, craters in the earth, and meteorite crashing into the earth are all kinds of things that we can observe. They may be called theory only in the sense that we can't observe them now. They happened many million years ago. We are making inferences from our present observation of gases in the earth and so on to past events such as huge meteorites hitting the earth, killing the plants, and killing off the dinosaurs along with many other living species. Since we cannot witness these past events now, we could say that what went on then is a theory. We might say that statements about dinosaurs are theory because what they are about is too remote in time to be observed. And that statements about electrons are theory because what they are about is too small to be detected through our senses.
Last is the theory in physics. I know, physics, philosophy, how can they relate to each other? Well, physics and philosophy are complex and multifaceted, with each discipline influencing and challenging the other. To add, according to John Hospers, physics is the principal stamping ground of scientific theory. Using physics, we can extend our understanding towards the cosmos. Take metaphysics for example. Physics often deals with questions about the fundamental nature of reality, and which lead to formulation of theoretical concepts in different philosophical domains. Now, furthermore, as stated by John Hospers, the ultimate constituents of matter, which means unobservable by the senses or through imagination. It is like imagining a scientist cannot explain things they observe by means of others they observe. They attempt to explain the observed by the means of the unobserved, and sometimes the unobservable. Next, a follower of Democritus named Lucretius had a book entitled On the Nature of Things, which relates physics and philosophy by simply stating that most things are material things that are composed of tiny particles. Just like chalk, it is formed after the composition of millions of tiny chalk particles. However, not everything cannot be explained. This is why John Hospers included the brute fact, which means that is the way reality is, and we can say why it is that way.
For the explanation in biology, we utilize explanations of a kind that is different from the one used in physics, astronomy, and inorganic chemistry. We use the idea of purpose in order to define living organisms. For instance, the bird flies about in order to gather materials for building its nest. Arctic mammals are often white, which provides them protective coloration against the background of snow. These flowers are composed of a sticky substance in order to catch flies. We perceive that these living things are imbued with purposes and that they do what they have to do to achieve their purpose. On the one hand, explanations that deal with purpose are no longer acceptable when evolutionary explanation is involved, like the Darwinian theory, survival of the fittest. For example, the Arctic fox is white for the purpose of survival. It serves as a protective coloration to blend in with the snowy background, which decreases the possibility of it being preyed upon. This aids them in surviving and passing those genes on to their offsprings. It often seems that the creature is inclined with a purpose and execute things to achieve them. What can we say about these purposive explanations? To answer this question, these are several ways in which the word purpose is used. Number 1, we explain why a person does what she does by saying her purpose is in doing so. For instance, why did you go to the mall yesterday? To buy some clothes. The person did what they had to do to achieve the purpose in mind. In terms of animals, we ask why the dog scratched the door. It's because it wants to get inside. Number 2, we also use the term purpose in another sense. What is the purpose of a remote control? To switch channels. What is the purpose of a notebook? To be used in note-taking or journaling. The remote control and notebook aren't living things imbued with purposes, but they have it in the sense that they reflect the purposes of humans who created these things. Finally, there is a more puzzling case. One might ask, what is the heart's purpose? To answer this question, to pump blood throughout the body. The heart is a part of an organism, but it doesn't have a consciousness. Hence, it cannot be explained in the first sense of purpose. It is also not developed manually or manufactured by humans, therefore it cannot be explained in the second sense of purpose. It doesn't reflect humans due to the fact that it wasn't created by them. One might ask what purpose that God has in mind in making human beings with hearts. But that is a different question. So what is the explanation of the heart? What role does it play? Or what does it do? If one might want to call it a purpose, it is only in the sense of function, not as any conscious motivation. To answer the questions, this is where evolutionary biology comes in to provide explanations. If an animal was born without those features crucial to life, then it will die and not reproduce like a creature without a heart wouldn't live longer. For example, mountain goats have hard, rough-surfaced feet, but those who did not have them fell down the slippery slopes and died. The ones who survived and reproduced had feet with better traction. Living organisms' characteristics and behavior can be explained by referring to evolutionary survival as a principle of explanation, but this denotes that organisms are already here, causing such questions to arise: how did they get here, or where did they came from, and how? Due to this, there is still an ongoing controversy for those who believe in divine creation and those who use evolution from inorganic substances as an explanation.
So let's move on naman sa emergence and reducibility. Let's define each of these. First, let's have emergence. A property is emergent if it is a novel property of a system or an entity that arises when that system or entity has reached a certain level of complexity. That's according to Internet Encyclopedia of Philosophy. Next we have is reducibility, able to be made simpler or smaller in size, amount, degree, or importance. That's according to Cambridge Dictionary. There are different levels of reality in the universe. The universe is composed of inorganic matter. Did you know that? But here on Earth and even somewhere, we still don't know this, are living things which grow, reproduce, and die. When living things achieve a certain level of complexity, something else happens. They become conscious. So what do you mean by conscious? They are aware of their environment, they can feel pain and pleasure, desire, frustration, and many more. There are qualities of things that are said to be emergent. You could not have predicted them from even a complete knowledge of what went before. They emerge at a higher level than anything that preceded. For example, water is composed of hydrogen and oxygen. Both are gaseous, right? But the two together form water, which is not gaseous but liquid at ordinary temperature. It is strange that when two elements are combined, they can form something different or they can form something new. So next is complete knowledge. Our knowledge was incomplete until it did enable us to predict the properties of a certain element. A complete knowledge would enable us to predict a certain thing. For example, tumingin tayo sa sky tapos napansin natin na cloudy. So, ipapredict na natin na parang uulan. Pero still, it doesn't mean na porket we are capable of predicting something, complete na agad yung knowledge natin. Dahil masyadong malawak ang mundo at marami pa tayong hindi nalalaman dito. I believe na kahit yung most intellectual na tao sa mundo is may mga things pa rin siyang hindi nalalaman. Let's move on to the level of reality. From the word itself na reality, this means kung ano yung mga totoong nangyayari sa mundo natin, kung paano umiikot yung mga nangyayari sa araw-araw. It is often discussed in the context of metaphysics, which is a branch of philosophy concerned with the nature of reality, existence, and the fundamental structure of the world. Another meaning of reducibility is based on the book of John Hospers. It refers to the idea that complex phenomena, concepts, or entities can be explained or broken down into simpler, more fundamental components or terms. The concept of reducibility is widely discussed in various philosophical disciplines including metaphysics, philosophy of mind, philosophy of science, and ethics. Basically, it is like a wide range of idea or concept na mas pinasimple para mas maging understandable. Next is the relationship of emergence and reducibility. The concepts of emergence and reducibility are closely related in philosophy, particularly in the context of understanding complex systems, phenomena, and their relationships. Both concepts pertain to the nature of explanations, how different levels of reality relate to each other, and the possibility of breaking down complex entities into simpler components.
Now, to the very last, creation versus evolution. In the book of John Hospers, a creationist and an evolutionist are having a conversation on how life is formed. The creationist said that the odds against living things originating from non-living things is far different than taking place beyond all imagination, as written in Human Destiny, a book of Pierre Lecomte Denouet. In response, the evolutionist said that the occurrence of life in the universe is vastly improbable. There is not one known instance of life among all things. Creationist theory even may be probable, or even how would one amass evidence for it? It's a scientific dead end, according to evolutionists. However, creation God may sound mysterious and not open to verification by scientific method. But existence has to be explained in some way or another. How did we get here? Who made us? And who made all of this? There must be one creator. As for evolution, it provides some coherent explanations of how living things evolved. Just like the theory of evolution of Charles Darwin, that man today is the evolved form from the apes before. Nonetheless, after all, evolution and creation do not exclude each other.